Okay, so welcome back to Lecture 7, our second lecture about scientific concepts. So let's continue. Now, we need to talk about measurement. Now, when we look at the world around us, we need to measure things. So you measure the height of a table to make sure it fits your living room or your kitchen. Same thing with concepts. So when a concept is a variable, we need to measure it so we can tell how big it is or how small it is or where it fits. So some concepts like gender have two values. They have male, female, black, white. So these are what we call binomial variables. Binomial, bi, to, nome, names. Other concepts like race or nationality may have many variables: black, white, Asian, etc. English, French, German, Dutch, so on. We call these categorical variables because we're putting the people into different categories. Now, some concepts like age are a number. So how old are you? I'm 22, let's say. That's a number. We call those numerical variables. There's a few other odds and ends, but let's keep it simple right now. Now, how do variables work? When we measure different variables, we can then say things about them. So look at this table. What does it tell us? So we have two concepts, gender, and we have watching sports. So some people watch sports, some people don't watch sports. Of course, you can have other categories in there, such as watch sports sometimes or something. So what does it tell us? Now, we have two concepts, but notice that gender only has one category. So there's no variation. So we can tell from this table, 70% of the men watch sports, 30% don't watch sports. So we can say more men watch sports than don't watch sports. So we can say something about watching sports with regard to men, but we cannot say anything about women. We cannot say that men watch sports more than women because women is not a variable in this population. In other words, gender is not a variable. Now look at this table. Now we have women as well. So we have two variables. We have watching sports and don't watch sports. That's a variation of the concept of watching sports. And then we have male and female. Those are variations on the concept of gender, right? So now we can say, okay, more men watch sports than women because 70% of the men watch sports, only 30% of the women watch sports, and vice versa for don't watch sports. So now we conclude that gender has something to do with whether or not people watch sports. Now, just as a note, I just made these numbers up. So don't go around telling people that men watch sports more than women. It's just made up. Now, another thing to keep in mind is independent and dependent variables. The independent variable is the concept that in our model is not caused by any other variable. Now, of course, in reality, they're caused by something else. But our model is limited to asking one question. So if we're asking about the relationship between gender and watching sports, then one of those is an independent variable, even though it's caused by something else. The dependent variable is the concept that in our model is affected by the independent or causal variable. So in the previous table, which was the independent variable and which one was the dependent variable? Was gender the independent variable or was watching sports the independent variable? So the question is, which one affected the other one? Now, the answer to this, we have to rely on logic, because gender cannot possibly be affected by watching sports. You're not going to become a man because you watch more sports. or you're not going to become a woman because you don't like to watch sports, right? So the gender is the independent variable, and whether or not you like sports, that is your dependent variable, right? Now notice does not mean that gender determines whether or not you like sports. We're not saying, oh, all women like sports or all men like sports. No, this is only a tendency, and it may be due to many factors, which later on in the course we can discuss. So, concepts of research, correlation. Remember we discussed this before. As one variable changes, so does the other. A positive variation means if one concept increases, as one concept increases, so does the other also increase. So here, for example, we have hours of study and how well you did on the exam. So the more you study, the more hours of study, the better you do on the exam, right? That would be a positive correlation. On the other hand, you might have hours drinking before the exam and your score on the exam. That would probably be a negative correlation. The more hours you spend drinking, the less well you're going to do on the exam, most likely. So a negative correlation means as one increases, the other one decreases. It goes in the opposite direction. Now, a spurious correlation, we mentioned this before, this is a false correlation in which both variables are being affected by another third variable. So, for example, as your shoe size gets bigger, so does your math skill. Does this mean your math skills are located in your shoes or your feet? No, you would say, well, you grow older, and as you grow older, your feet get bigger, and so do, hopefully, your skills at math. So they're actually caused by your age, not by any relationship between shoe size and math skills. So that looks like a relationship, but it's not a relationship. It's spurious. Here's another example. During some parts of the year, ice cream sales go up, and so does crime. During other parts of the year, they both go down. So there seems to be a positive correlation between ice cream sales and crime, right? So does this mean that ice cream causes people to become criminals? Or maybe being a criminal makes you eat more ice cream? No. Both are caused by the weather. When it's hot, people eat more ice cream, and people are more likely to do crime. When it's cold, especially if it's very cold, everybody stays home, nobody eats ice cream, and even the criminals don't go out because it's too cold. Here's another example. Observations show that areas with large numbers of storks also have high birth rates. So there's a positive correlation between the number of storks and the birth rate. Does this mean that storks bring babies? No. In this case, birth rates and the number of storks are both higher in rural areas than they are in cities. So in other words, the relationship or the apparent relationship between the number of storks and the birth rate is actually caused by this third spurious variable. So we can test for a spurious correlation by using a control variable, by taking that third variable into account. So for example, look at this table. These two variables, number of storks and birth rates, appear to be correlated in 20 different areas that we've looked at. But when we divide the areas according to our control variable, look what happens. Now, in urban areas, you notice all the urban areas have low birth rates and few storks, whereas all the rural areas have high birth rates and many storks. So in other words, when you look at the subtables, you notice there's no variation anymore. And without a variation, you do not have a correlation. So, sociology is obviously different from other physical sciences. We in sociology deal with social interaction, which consists of concepts, ideas, values, many other things which are not physical. Therefore, they can't be measured directly. Think about many of the most important things in life: love, hate. How do you see love? You can't see love. You can see manifestations or indications of love, perhaps, but they might be indications of something else. Somebody might bring you many flowers. Do they love you, or do they just want your attention, or they want something else from you? Keep in mind, though, that many of the core concepts in the physical science were also not immediately perceivable, such as bacteria, viruses in medicines, cells in biology, atoms in chemistry, light waves in physics. All of these things were theorized before they were actually seen. Indeed, core concepts like gravity and evolution can still only be detected by inferring them from their effects. So this is not necessarily a problem unique to the social sciences. So this does create some issues or problems of methodology. The biggest problem in the social sciences is that we are dealing with people. The people can change their behavior, and there's something called the Hawthorne effect. The Hawthorne effect is basically when people know they're a part of an experiment or they're being asked questions, they may try to change their answers to either please the experimenter, the researcher, or maybe piss him off. So they may try to give false information in order to get some other effect out of the experiment. So this is a very real thing, and it means that we have to be careful when we're doing research not to affect people's behavior. There are also ethical issues. We cannot cut people up in a laboratory like frogs. We cannot do things to people that may cause lasting damage. Like, let's say, let's have an experiment where we beat 50 children every day for a year and see what happens. And another 50 children will give them ice cream. Right? We can't do that. You cannot do something to people that may have a negative impact on their well-being or their psyche or their status. So that means a lot of things that in the physical sciences you can do, like measure the number of bacteria in a petri dish. You can't do this in the social sciences. So does limit us to some extent. However, human behavior is generally predictable, which ultimately is what makes social life possible. If we could not predict to a certain degree of accuracy the behavior of other people, we would be living in chaos, right? So this means that since social science is looking for those predictable behaviors, they are there and they can be seen and measured. I'll give you an example. Emil Durkheim, who we talked about before, one of the fathers of sociology, he wanted to show that social solidarity was an important social fact even at the most individual level. But nobody had ever seen, quote unquote, social solidarity in action. It was a concept. So he took one of the most individualized actions, suicide, to argue that it was in fact affected by social behavior. But how to measure social solidarity without a very complicated survey, which he didn't have the resources for 200 years ago. So he used another variable, in this case religion, as a substitute variable, as a substitute for social solidarity. So arguing that Catholics had more social solidarity from their religion than Protestants, because Catholics go to Mass, Catholics have confession, they have communion. So in other words, Catholics have a sense of support from their church, which Protestants don't have, or at least not to the same extent. So he hypothesized that Catholics would have more social solidarity and thus be less likely to commit suicide than Protestants. So he's using a substitute something that substitutes for the variable he's interested in, but that he believes is related to the core variable. So he's using religion as a substitute for social solidarity because he believes it is related. So then he did a comparison of suicide rates across different areas of France and Germany, Protestant areas versus Catholic areas, and he found that in fact areas with more Protestants had higher suicide rates. So this is a diagram to kind of show his method. So his theory was social solidarity prevents suicide. The hypothesis would be people with higher social solidarity will have less suicide or are less likely to commit suicide. But he couldn't measure social solidarity directly. So this is his main concept here, his main hypothesis, that social solidarity has a negative impact on suicide, a negative correlation. That's his hypothesis. But he couldn't measure social solidarity, so he substitutes religion, in this case, whether or not somebody is a Catholic. He then goes ahead and does the correlation between the substitute variable, religion, and his target dependent variable, suicide. And he finds that there is in fact a negative correlation. Now, there are obviously problems with this method. There's a couple problems. One is it valid to take religion as a substitute for social solidarity? And also, he's using large regions rather than actually seeing is it Protestants or Catholics who are more likely to commit suicide. So his method wasn't perfect because of the limitations of the data or the instruments, the tools he had available. But it's the same thing with Isaac Newton. Isaac Newton couldn't look directly at many of the stars that we can see today that now prove that his theories were correct. So the same thing is true today. Now we can use much more advanced technology to measure these things. We can do surveys. We can do much more specific analyses of these things. And in fact, we find by replicating Durkheim's study using different techniques, we find that it seems to be true. So many different ways of looking at issues of solidarity seem to relate to suicide. So for example, people who live in very rural areas tend to commit suicide more often than people who live in more concentrated areas. Again, this would tend to indicate that the people in concentrated areas have more solidarity, more social support, and therefore are less likely to commit suicide. Other studies, for example, show people who live in very cold areas, again, have higher suicide rates, again, because hypothetically, they are more likely to stay inside because it's cold, less likely to be with others on a regular basis, so therefore have lower levels of social solidarity. So thank you very much. This is the end of section 1, lecture 7. Hope you enjoyed it. And before taking the quiz, as usual, make sure you check the companion for any additional work. Thank you. Bye-bye.